All right, so I went through the progress checks this morning, and I got a bunch of questions that we need to go over. Okay. So the first one is number one for part A. And this is, this is something that doesn't come up very often, but it does come up, so you have to be ready for it. This is calc active. We want to find the second derivative. Oh, wait a minute. So we got to find out what value of t the second derivative is equal to 1. So we got to get the second derivative first, right? So the first derivative, the slope, dy dx is dy dt over dx dt, right? So we're given dy dt and dx dt, so that's t to the 7th minus 2t to the 4th over 3t squared. Now the second derivative of y with respect to x is the derivative of this divided by dx dt again. Okay? So the second derivative is the derivative of y prime with respect to t over dx dt. My guess is you missed the dx dt. Okay? So we want to take the derivative of this, which actually this simplifies, doesn't it? Yes.
Isn't it dy prime dx, not dt?
Nope, dt. Because this is in terms of t.
Oh, okay.
Right?
Oh, yeah.
So dy prime dx is this. Okay? The derivative of y prime with respect to x is the second derivative. Because that's where that's why dx is squared in the denominator. Because it's dx dx. Okay? So this simplifies into 1/3 t to the 5th minus 2/3 t squared. So that makes that the derivative of this pretty simple, right? So now we have what? 5/3 t to the 4th minus 4/3 t, and then divide by dx dt, so 3t squared. And then we can simplify that to be able to solve. So we get 5/9 t to the 2nd minus 4/9 t to the -1. And we want to solve that equal to 1, right? Okay, and we can let our calculator do that. So we got 5/9 t squared. Minus 4/9 t to the -1. Equals 1, and we want to solve for t, and then hopefully this is going to get us an answer. Oh, t squared. So I don't think that's right. What's that? We get -1 or negative this or 1.524. Any other answers? Any of those the solution? 1.525, yep. 1.525 is the rounded version of that. So that's D. So I did mention that on the day that we did derivatives of parametric. I don't know that you had any questions that asked you for that along the way, but that's what you have to remember that for the second derivative, okay? All right, next up is number 6. So we have this is no-count. Curve defined by the parametric functions x and y. What is second derivative of y with respect to x? So again, same thing. Okay? So we got to, here we have to find dy dt and dx dt, right? So dx dt is 2e to the 2t. dy dt is 4e to the 4t plus e to the t. So dy dx, 4e to the 4t plus e to the t over 2e to the 2t. That can simplify. We get 2e to the 4t minus 2t plus 1/2 e to the t minus 2t, so that's negative t, right? Now to get the second derivative, we need dy prime dt, which is the derivative of this with respect to t. So that's going to be 4e to the 2t plus negative 1/2 e to the negative t. So the second derivative is this divided by this, right? I got everything right here so far? So that's 2. And this is minus 1/4 e to the negative 3t. Which is that? Okay. All right, let's look at 7. Hey, look at this. Second derivative again. Seems to be a pattern here. The x dt is negative sine of t. Dy dt is cosine of t. Dy dx is cosine t over negative sine of t, which is negative cotangent of t, right? Just, it's easier to take the derivative of cotangent, isn't it? So the derivative of cotangent of t is negative cosecant squared, right? We already have a negative there, so we get positive cosecant squared of t. Oh, what am I doing? That's this is this, right? Dy prime dt is cosecant squared t, right? Okay. And so the second derivative is cosecant squared of t over negative sine of t. Well, that's 1 over sine squared, so negative 1 over sine cubed. Like, these are the kind of things that you got to make sure you're doing, because if you're doing quotient rule, then you get all locked up in all kinds of weird things, probably, right? Okay. Okay. Let's look at 9. Different, maybe something different. All right, so the curve, a curve in the xy plane is given by the parametric equations x of t, y of t. The graph of x of t is shown on the left, and the graph of the derivative of y is shown on the right. Which of the following integral expressions gives the length of the portion of the curve described by the parametric equations for 1 to 3? All right, so for 1 to 3, x of t is a line. What line is it? Well, its y-intercept is 6, and its slope looks like -2. So on 1 to 3, x of t is equal to -2t plus 6. Okay. And y prime of t is also linear. Its y-intercept is 1, and the slope is 1. So y prime of t is t plus 1. So the length of the portion of the curve given is the integral from 1 to 3 of the square root of x prime of t squared plus y prime of t squared, right? We already have y prime, it's t plus 1. This is where I assume a mistake might have been made. Okay? The derivative of x is -2, so that's -2 squared plus t plus 1 squared, which it looks like they've simplified, so we got to do a little bit of algebra now, right? So t plus 1 squared is t squared plus 2t plus 1. And then that's plus 4, so t squared plus 2t plus 5. I don't think you can do anything with that. And there it is, b, right? Okay. Did we take the derivative of dy dt? And I bet that. No. Taking the derivative of dy dt, that answer is not there, right? Because if you take the derivative, you get 1. Oh, did you put this in there? Is that d? Put this in for x, is that d? Does that come up to d? I don't even know.
I think it's somewhat close to D.
It's close to d, yeah. All right, let's look at 15. Make sure if you have questions along the way, you're asking, all right? The velocity vector of a particle moving in the xy plane has components given by dx dt equals t squared and dy dt equals e to the -2t. The initial position of the particle at t equals 0 is 3 - 5. Which of the following expressions gives the particle's position x of t, y of t? So what do we use to find the positions?
Fundamental theorem.
Fundamental theorem, right? So we need to know a value and the rate of change, right? For each of the components. So do we know a value for x? 3 at t equals 0. So we know x of 0 equals 3. And we know y of 0 equals -5. So we need to use both of those numbers, right? So for x, we got 3 plus the integral from 0 to t, right? This is x of t. So from 0 to t of that, we need to change the letter. Okay, I use q, but this is using s, so what's the difference, right? Doesn't matter. Okay, so I'd write q squared dq, and that looks good. No, that doesn't look good. That looks good, right? So I don't think we have to do the other one, do we? That's from 3 to t, that's wrong. No 3, no 3, answer must be C, right? So we can shortcut this multiple choice question by finding our first answer, right? Of course, the second answer is -5 plus the interval from 0 to t of e to the -2q dq. Okay. Okay, so those were all the ones that had a bunch of wrong answers on A. So now let's look at B. Oh boy. Look at this. So I did show you this spiral at one point, right? Where R is equal to theta. So, if R is just equal to theta, then theta is just getting bigger and bigger and bigger as theta is getting bigger, right? So that means R is getting bigger as well. So that's why it spirals out like that. Now here we have to find the area of the shaded region. So we need to know where it's starting. Well, at 0, R is 0, isn't it? Okay. Well, that is a boundary of that region, isn't it? Okay. So theta equals 0 is a boundary. And then as theta goes up, it's only going here though, isn't it? Right? So as theta goes up, the graph is doing this. So we have to actually wait till we get back to 2 pi, don't we? Right? So this shaded region is something to do with the integral from 2 pi to 3 pi, isn't it? Okay. Now the problem is it's not all of it because we have that taken out of it. So it's the integral from 2 pi to 3 pi of 1/2 r squared d theta, which is theta squared, right? Okay, so I'll just replace that. Minus, oh, we started going in this direction, didn't we? So that's from 0 to pi, isn't it? So we subtract out of that the integral from 0 to pi of 1/2 theta squared d theta. Yes.
Can you explain why you're only getting the top half when you take the integral?
Top half of what?
Well, like in a normal integral, if it was below the x-axis, then you'd be minusing the stuff that's below the x-axis. But you're able to just take it from 2 pi to 3 pi, and it doesn't factor in anything that's below the x-axis.
Well, 2 pi to 3 pi is from there to there.
Oh, I see what you're saying.
Right?
Yeah.
So you're getting,
No.
when you're going from 2 pi to 3 pi, you're getting that. And the reason why you're getting this area too, because you're getting all of that area. Remember how it's sectors, right?
Uh-huh.
Okay. And by the way, there is no negative area in both.
Yeah.
Right? Because you're squaring R, aren't we? So it's always positive. And it's always area, so it's always positive. Area is always positive no matter what, right? Even in Cartesian, when I ask you for area, you have to negate those integrals under the x-axis, right? But the reason why you get negative in Cartesian is because the representative rectangle has a negative value to the height of it, doesn't it? Assuming you're going from left to right, your dx is positive, but your f of x is negative. Here, we're always using r squared, so we're always accumulating area, right? But another question people might have is, why are we getting this area if we're going from 2 pi to 3 pi? And the reason is because the way conceptually we think about polar area is that it's always think about it as you're getting the area of shading from the origin to the curve for the entire interval, right? And of course, that means we're shading in this portion along the way, aren't we? Right? Whereas when I only go from 0 to pi, I'm only going out to the curve right there, right? So I'm only getting that amount of area. So, oh, now I gotta get this. Well, we can do this antiderivative, right? So the antiderivative of theta squared is theta cubed over 3, so that's theta cubed over 6 from 2 pi to 3 pi, minus theta cubed over 6 from 0 to pi, right? So 3 pi cubed minus 2 pi cubed over 6 minus pi cubed minus 0. All right, what do we got? How many pi cubes have we got? We've got 3. I'm sorry, we got 9. We got minus 4. So minus 5, so that's 4. That last pi cube is also okay. We have 4 pi cubes in the numerator. Are we okay with that? 9 minus 4 minus 1. So we get 4 pi cubes over 6. Pi cubes over 6. Oh, it's cubes. Cubes. Always the arithmetic. 27 minus 8 minus 1. How about that? 27 minus 9, that's 18. That's 18 pi cubed over 6, and that's 3 pi cubed. Oh, okay. All right. There's a bunch of these on the list, these kind of things. So let's look at the second one, which is number 5. That was number 10. Number 5. Figure above shows the graphs of the polar curves r equals 3, r equals 4 sine theta. What is the area inside the circle? R equals 4 sine theta, and outside the circle, r equals 3. So inside the circle, so you got to know which one's which, right? R equals 3 is a circle centered at the origin. Okay? So we are outside this circle, but inside this circle. So we're looking at this area. Okay? So we have to find the intersections here, don't we? Now, let me show you a little secret on a calc active question. You do not have to be in polar to find those intersections. Sine? Sorry. So the intersections go from, so it's from here to here. So we're looking for a first quadrant and a second quadrant angle, right? So we're looking for a number between 0 and 1.57 and from 1.57 to 3.14, right? We're looking decimals. So if we do our intersections here, that looks good. And that looks good. So both of those meet the criteria. So those are the two intersection points. Okay. And what are we doing? We're solving for sine of x equals 3, aren't we? Well, we know how to do that. Okay. And you can do it. You can also do it on the calculator screen. Okay. And get those numbers as well. But at any rate, so remember we can store this as A and store this as B. That's the right click. You guys will just tap the bar key and you can open it up as well, right? And so now I can go back here and I can find the integral from A to B of, now which one's the outside? So it's the, let's just do the two integrals. So it's the outside this, so the top integral is the 4 sine theta integral. So this is 1/2 times 4 sine, I'll use t squared, arrow outside of that, minus, probably do this one with sectors, but I'm just going to do it. That's just 3 squared, right? That look right? That's right. Is that B? .246. Yep, that's good. Okay. So if it's calc active, you can go ahead and do that. I mean, it's not a special angle, right? Because it's sine theta equals 3/4. Okay, so we don't know what that angle is anyways. So you're going to have to use your calculator in some manner to get those intersections. Are we okay with that? Yes.
You go around like assign the x value a variable.
What's that?
You go around and assign the x value a variable. Calculator again.
You hover on the number.
Yeah.
And tap the var key.
Okay.
You used your calculator?
Yeah.
So you hover on the number and you tap the var key and it says store var or something like that. One of the menu items.
Yeah. And
then you just type in select that and then just type in the letter you want to store it as.
Okay.
Good. If you're on, you can also hover and then tap control menu, and then there's a store on there as well. Control menu is a right click on the handheld itself. Okay. Anything else? Yeah.
So how do you know it has to, like, how did you get the two, like, intersections of those two intersections?
Because I know I'm in the first quadrant and the second quadrant. And they're the first two intersections along the way, right?
So from like 0 to 2 pi or something?
Well, from 0 to pi over 2, first intersection is from 0 to pi over 2.
Oh, okay.
As a decimal, that's 0 to 1.57, right?
Okay.
Okay. And as a decimal, from pi over 2 to pi, that's 1.57 to 3.14. So those are the two intersections in those domains, right? Anything else? All right, number 1. The position of the particle moving in the xy plane is given by x t, y t, where x is that and y is that. What is the speed of a particle at time t equals 3? What is speed?
Square root of x prime.
Well, okay, so it's always what? And then specifically for parametric, it's going to be that. But it's always what?
Absolute value of the velocity.
Absolute value of velocity. And the way we do absolute value in 2 dimensions is Pythagorean theorem. That's how I want you to think about it, okay? So, yeah, square root of the sum of the squares of the velocity component squared, right? Okay? So we need, so once we get, so speed is always absolute value of velocity. Okay? Always. It's even Pythagorean theorem in 1 dimension if you really want to think about it, right? Okay? You just have a 0 component in 1 direction, and you take the square root of something squared, well, you get the speed. Okay? So we need dx dt and dy dt, don't we? But actually, we don't need to. This is a calc active question, right? So we can find the derivative of that at 3 and the derivative of that at 3. This is polynomial, so you probably want to do this by hand, right? If this is not polynomial, then you can let the calculator do it. So let's just do x prime. So x prime is 3t squared plus 2. And so x prime of 3 is 927.29. And y prime is 10t. So y prime at 3 is 30. Everybody agree with those? So the speed is the square root of the sum of those squared, right? Which comes out to, I think you can handle typing that in your question. Okay? All right, 11. Look at this cool crap. Figure above shows the graphs. We calculated here? No. That's interesting. Figure above shows the graphs of the polar curves r equals theta, r equals 2 theta plus 1 for theta between 0 and 2 pi. What is the area of the region bounded between the 2 polar curves over this interval? So we know what the interval is. It's 0 to 2 pi, right? So we're looking for the area between the 2 curves, right? So that's simply the area of this curve minus the area of this curve. You just gotta know which one's which, right? So this inside curve is r equals theta because that's the one that starts at 0, right? This curve is r equals 2 theta plus 1 because that's the one that starts at 1. Or at least that looks like it's probably 1, right? Certainly not 0. So integral from 0 to 2 pi, 1/2 outside curve, 2 theta plus 1 squared d theta, minus integral from 0 to 2 pi, 1/2 theta squared d theta. And that comes out to, oh, this is no calc, huh? So I would probably square that out to do the antiderivative, right? So that would be what? 4 theta squared plus 4 theta plus 1, right? So we get 1/2 times 4 theta cubed over 3 plus 4 theta squared over 2, so that's 2 theta squared plus theta. We're running that between 0 and 2 pi. And then this is gonna be theta cubed over 6. Between 0 and 2 pi. So if we plug in 0, we get 0, so that's good. So we only have to plug in the 2 pi's. Just a half. Oh, no, I didn't. So we get what? If I plug in, so I get 1/2 times 2 theta cubed is 8 pi. 2 pi cubed is 8 pi cubed, so that's 32 pi cubed over 3. Squared is 4 pi squared, so that's 8 pi squared. 2 pi. And this is just going to be 8 pi cubed over 6. So that's 32 pi cubed, so that's going to be 24 pi cubed over 6, which is 4 pi cubed. Okay, so that's leaning towards D, huh? And let's just check the rest. That times a half is 4 pi squared, checks out, and that times a half is pi, so that checks out, so that's D. Okay? All right, number 4. Oh, big one. Calc active. What is the area of one petal of the polar curve r equals 7 theta, sine of 7 theta? Shown in the figure above, note a petal is a loop of the curve shown above. So here's the thing, we got to get that one loop. So we're going to do that one petal, right? That's the one we want to do. When theta is 0, we're at 0. And as theta increases, we're going to run along this petal until we get back to 0, right? So we need to know when sine of 7 theta is equal to 0. Again. Okay? So that means 7 theta is going to be pi, right? That's the next time that sine is equal to 0, past 0. So theta is equal to pi over 7. So we want the integral from 0 to pi over 7 of 1/2 sine of 7 theta squared d theta. And if you plug that in your calculator, you should get A. Okay? Let's try one last one. These weren't as much as the others, but okay. So test tomorrow. Okay. I will see you guys here.
Is it a one-day